Hi everyone, welcome back to the channel called Engineering Beyond Blueprint. So this has been almost 2 weeks now. I didn't kind of connect with you all, right? So today I came with two different segments. One, we are talking about one of the tool which is in development stage, as a name it called Engineering Beyond Blueprint as a component matchmaker. And that is tool is basically used to for design engineers, product line manager, product managers, and design engineers, and supply chain management and component engineering roles as well, right? So it's kind of a very quick reference guide as an AI tool which is in a development stage now. So that give quick reference insights of those AI driven tool, right? So I would like to share the demo session today so that you will be understanding what is the importance of that tool and how it is going to game changer for you to grow in the career life, right? So and let me quickly share you the demo part of it. Then I would like to hear the feedback from you so that in couple of months I'm going to release in the production version so that you can easily to access it and make use of that tool, right? So if you had any kind of feedback post this demo session, please do put in the comment section below so that I can just read through and see whether we can accommodate those kind of deployment part of it so that it's easy to access and or make use of that effectively. This is what the tool we are talking about, Component Matchmaker. This is advanced granular risk analysis tool. So here I do had performed using these two part numbers had been performed already. So anything which we kind of logged here and search with the part numbers, as you can see, the history search will be in the left side of the panel. Like as a for demo purpose, I will make use of this one which we already searched recently. So moment if you put this part number, this is the view which you could expect out of this tool. And you can see what is the risk awareness as an engineering report, and you can see the confidence level as 100%. That means it is whatever solution we found is 100%. There is no form fit function impact. So as a summary part of, if you see, it says as an analysis summary, targeted part number is this and the commodity is n channel power MOSFET, and this is put as an active but getting obsoleted in another 5 years. So when you see this part number is foundational N-channel MOSFET, while still in production by several manufacturers like Vishay, ST, and so on. The N suffix version of this part number from the Infineon or formerly called International Rectifier is the industry standard drop-in replacement, offering significantly improved RDS and the current handling within the same TO220 footprint. So when you see the one-to-one comparison table, so I've been mentioned like which is the original manufacturer and what is the proposed solution from which supplier, which manufacturer, and similarly who are the suppliers. Like DGK is one of the preferred supplier across all the industry. And coming to like supplier part number is the DCK part number, I would say. And this is what we called manufacturing part number and recommended replacement solution. When you see the life cycle status is it active, as I said, the existing part number will be available only in the 5 years, whereas the recommended solution will be available next 10 years. So that is where we call this as an upgrade, as a delta and verdict, right? And when it comes for the estimated pricing is $1.45, whereas the recommended solution having $1.18, which is lesser than in the terms of cost when you see the existing one. So we can see the distributor stocks also, and you can see the packaging, and we see the technical parameters, better, not better, or upgraded, and so on. And you can see the power dissipation, and you can see overall engineering road notes and the risk assessment part of it when it comes for recommended solution. So there is a minor change, as I mentioned, the lead-free version has slightly lower maximum power dissipation rating, which is 130 watts compared to the same legacy Vishay of this, as per datasheet is 150 watt. Because the RDS value is significantly lower, the actual heat generated in the circuit will be lower for the same current. This risk considered to be negligible in the 99% of applications. So then when come for redesign requirement, as you can see, the AI tool give a very prompt response for you saying that no redesign required. The reason is the IRF 540 NPBF is a direct drop-in replacement for the IRF 540. The pin node, gate, drain source, and the physical dimensions are identical. The improved electrical parameters of this and this provide additional safety margin for existing design. So this is one part of information which you receive. And similarly, I've been kind of used another part number, which is cable supplied by 3M. So when you search by with this part number, this is getting obsoleted near future, like in 5 years. And the recommended solution is available more than 10 years. So similarly, here also, if you see the targeted part number is this, and the commodity type is high temperature flat ribbon cable, right? And as a life cycle status, if you see it is active, but having higher lead time issues, right? So given that in mind, so keeping supply chain management with the flow, right? We should have the part readiness in the manufacturing. So given that high lead time issues, so we had got a proposed solution which is available in the stock, right? So again, this also having the same set of information. You can see all the technical parameters, life cycle status, and the cost of the part number. This is very reasonably less compared to the existing or getting obsolete part number. And you can see the distributor stocks, and you can see the all other different parameters, right? So there is a change in material, but it's not a major risk as such, right? So then you can see as a part of engineering note, the minor risk, if you see, uh, PFA is slightly more translated clear than FEP, which is typically more opaque white, which is cosmetic difference. That is only the cosmetic difference, as you can see. And the minor risk in terms of mechanical, this is specifically marked for high flex life, while the 3604 uses same 19 strand conductor construction. The PFE insulation in the 3319 is slightly more resistance to the series stress cracking over the millions of flex cycles. If the application involves continuous motion robotic arms, verify the cycle requirement for the statics or the occasional flex use their zero risk. Right. So when you see the redesign requirement, it's not required any kind of redesign because this 3604 slash 10 is physically compatible with standard IDC, which is insulation displacement contact connector designed for 0.050 inch as a pitch ribbon cables, right? So I hope this is kind of pretty much summary about as a development part of which I want to share it with you as a dev. So you can make use of this and do let me know if you had any kind of suggestions or recommendations in the comment section below so that I can bring more improved version of the component matchmaker. Thank you so much for watching. Have a great day.